Hi, in this video we are going to discuss about the addressing modes of the 8051. The addressing modes and how instructions find data from the 8051 microcontroller. Based on this, we are going to discuss about the different addressing modes in 8051. First we see about what is addressing mode. And addressing modes define how the CPU finds instruction data. And now let us take the example. We think it is a library and immediate data is on your hand slip and direct data is at your specific shelf. Register data is already in your hand. So these modes impact speed, code size and flexibility. And first we see about what is immediate. It is the data which is directly part of the instruction. And direct it is a data that is used for specified memory address. And the next one is your register. It is the data that is located in a CPU register. Now let us see about the one by one addressing modes. 8051 architecture, data locations. The 8051 architecture, the data locations are internal RAM memory and SFRs and registers. And the general purpose registers R0 to R7 gives the fast data access, and the accumulative and B registers are crucial for operations. The internal RAM memory having 128 bytes and it is mainly used for the main data storage. And SFRs are the special function registers. It is available in the 80H2 FFH address and it is mainly used for the control of input outputs and the timers. And the registers, common registers, that is the R0 to R7, it is a general purpose registers, and the register banks like A and B. It gives the fast data manipulation. First we see about the immediate addressing mode. So for immediate addressing mode, it represents the hashtag symbol. That is, it is a hashtag symbol. It represents the immediate addressing mode. So it is ideal for loading constants. The value is directly included within the instruction itself. And it is one of the fastest way to load the data, and it does not require any memory for lookup as needed. The main concept of immediate addressing is the operand data is part of the instruction. The syntax which is used for the immediate addressing is move destination, hashtag data value. So for example, we are giving the 18H, the hexadecimal value, the 18H, and the value is want to move from move to accumulator. So we can write the syntax as move A, hashtag 25H. In this, the 25 value is moved to the accumulator A. That is one of the fastest data loading. So now let us see about some examples of immediate addressing mode. So first it is the move R0, hashtag 0 FFH. So the FFH value is loads into the register R0. So next one is add A, hashtag 10. The value 10, decimal value 10 is directly load into the accumulator A. Next one is your move P1, AAH. We know that P1 is a port pins. Normally we are having 4 ports, P0 to P3. So P1, so we can write the AA value to the port 1 pins. Next one is a move DPTR, hashtag 1234H. So we have to load the data pointer with a value of 1234. And next one is the immediate, first discussed about the immediate addressing mode. Now it is a direct addressing mode. So normally direct addressing uses an 8-bit memory address for specify the operand's location. In this, we are using the SFR, stack pointers, and the accessing internal RAM and special function registers. And it provides direct access to both data memory and input-output ports. The concept behind the direct addressing mode is exact 8-bit memory address. The syntax which is used is move destination, address. So for example, the 30H value is moved to the register A. And it is also the another example, move P2, A. The value of A is moved to the port 2. And some examples of direct addressing is move 55H, R7. So the stores R7 content in the RAM 55H. Increment 20H. So the 20H memory location is incremented. CLR P0.7. CLR means it is a clear bit. The clear bit 7 in the port 0. Move IE, hashtag 82H. I is interrupt enable. So we have to set the interrupt enable pin in the SFR using 82H. Next one is a register addressing mode. The register addressing, the operand is already residing within one of the CPU's internal register. So this makes the fastest addressing and fastest data movement from external memory. So it is ideal for rapid data transfer between registers and for arithmetic operations. The concept is operand is in the CPU register. Syntax used is move destination register to source register. So extremely it gives the fastest operation. Now comparing the addressing modes, we saw immediate addressing, direct addressing and register addressing. And immediate we are using constant value, and direct we are using RAM and special function addresses, and it is a CPU registers. Immediate it gives the very fast operation. Direct it gives the fast operation. Register gives the fastest operation. And for immediate we are using the hashtag symbol and loading fixed values 0F or something, and it gives the accessing variables, and the register transfers from R1 to the accumulator A. So from this we are concluding that immediate, direct and register addressing modes gives the fastest operation, and it should load B with OX, copy RAM and add two registers are the immediate, direct and the register addressing modes. Thank you.